Today I will give a short presentation about my project. I didn't do yet. I'm already working a year. So my project is on worms, actually, and you can call them oligochaetes. So this is a collaboration between a company called SR Technology and TU Delft. Then, after my presentation, which should be about 2 minutes, Stephen will present his project. So, we do research about the degradation of secondary sludge, which is produced in a normal wastewater treatment plant. The annual production in the Netherlands is about 500,000 tons per year. And this, to process, is very energy and cost intensive. As you can see, I will translate. Well, essentially, most of it is incinerated. So you're actually burning water. So we proposed an alternative process, which is the degradation of sludge by a natural predator, which is this tiny little animal. It's called Alophorus percatus, which is actually a bristle worm, and it's family of all the Annelida in this phylum, and also many other types of worms, including penis worms and nematodes. And the humans should be here, so we're closely related. So this is the percata, and it uses it to breathe. And you see here the digestive tract, and we suspect that it contains a lot of very active enzymes that it uses. Right. So it was discovered by Müller in 1773.
How big are them? How big are them?
They're as big as the hairs on my arm. They're maybe 2 millimeters. So they're very small. See them. So we designed a special reactor with optimal conditions to grow this worm biomass. And they grow on this carrier material, which allows them to stay in the reactor, that they don't wash out at low residence time. The volume of our full-scale reactor is 125 cubic meters. So the process overview will be, you have your wastewater treatment, this is your aeration tank, sludge is produced, there is a set line, and the sludge is fed, thank you, to the worm reactor, where it's degraded, and about 25% is degraded, and the rest is stored in this big volume storage tank. Now we discovered that when we tried to remove the sludge, it was almost disappeared. So a lot of sludge was further degraded in the process that happened here. And now we did a lot of research that could be responsible for this process. That's why I introduced Stephen, who did his Bachelor of Science thesis.
The storage tank, is that a sludge digester or is it just a tank?
It's just a big volume, it's just a lake, a tank, yeah, like a digester. But Stephen will tell you everything about it.
Yeah, good afternoon. It is indeed just a storage tank, no increased temperature, nothing. And we don't know what's happening, so this is why we are glad you are here. So if you have any comments or ideas, just interrupt me and we will discuss it, because we would like to know these answers. I did a bachelor end project. This is the title. The influence of worm predation on the anaerobic breakdown properties of waste-activated sludge. I couldn't make it any shorter, sorry. It will take about 20 minutes. First of all, introduce, and hopefully most of the time goes into the discussion, conclusions and questions. Okay, the full-scale operation is in Rotterdam, in Friesland. It processes 250 cubic meter waste stream containing 500 to 600 kilograms of dry solids. To verify it, this process works at different locations because sludge is not the same in every wastewater treatment plant. There are several pilot plants, they are 5 cubic meter, and different students are running them, keeping them in good condition. Yeah, you can see where they are. In the worm reactor, as Jan said, 25% of the solids are reduced. They are eaten by the worms, so to say. And this is why it is interesting to look at it is costly, 500 euros a ton. Jan had a very clear picture of the process. Two things I have to explain, the words I use. Where I refer to in, it means the input of the worm reactor, so that is waste activated sludge. It is sludge not containing any dissolved solids because in the aeration tank, in the normal process, the dissolved solids are turned into bacteria, so to speak. And the out, that is the output of the worm reactor, and this is deposited, stored in the buffer tank. Okay, our hypothesis is, we don't know if it is correct, but this buffer tank, because it is so large, it functions as an anaerobic digester. The temperature is in the winter about 12 degrees and in the summer about 20. 40% of the solids, total solids, is reduced in 2 to 4 months in this tank. Okay, we hypothesized that because of the way I did my experiments, that this is an anaerobic digester, but of course you have a large stream of water entering. The solids, they drop to the bottom, and the clear effluent is removed here. And we measured that, but we know that a large part of dissolved salts leave the buffer. So this is one of the processes that includes the high measured reduction of solids in this buffer. So anaerobic digestion and leaching. Right, this is a possible application of if it is true that these worms increase the metagenic activity, increase the biodegradability of the sludge. A possible application would be to use active fermenters for the production of iodine. This is probably known, but I will quickly make a summary. Anaerobic digestion starts with hydrolysis of suspended solids. There are no dissolved solids. There is no substrate directly for methanogenesis because it is activated sludge. So these are already removed. We only have suspended solids, and these are probably mostly bacteria, living bacteria, dead bacteria. Right. They are turned into volatile fatty acids. Acetic acid is